And we have ignition with the excitingness of kinematics problems. This is a basic one. There's a more complex version of this. So once you do this, if you're feeling like you're feeling really great, you might want to test out your challenger knowledge on the complex version, see how that goes. So let's get right into this one. We got a rather large man is running. Let's call him Szymanski. Awkward. He runs, giant quoties on that one, up a hill. He is experiencing a constant acceleration. I bet there's supposed to be a period here. Oh, well. What? No, no, no. Stop thinking, computer. Pens. Pen. Pen thickness. Sure, here's that. Runs uphill, period. He, capitalize that, is experiencing a constant acceleration of negative 0.003 meters per second squared. The hill is a 1,200 meter trek. How much time will it take him to get to the 800 meter mark if his velocity at the 0 meter mark was 22 meters per second? Second question is, how fast was he going at the 800 meter mark? So first thing is, I like to always list my givens. So we are told that my acceleration, I'm sure it's not me, it's some other guy who likes to run and kill himself. Acceleration is negative 0.003 meters per second squared. And then it says that time, we're looking for time. It's our unknown. We have an acceleration of negative 0.003. I already did that. Oh man, it's been a long day. It's been a hard day's night. And then I was told my velocity. That's what I was told. My initial velocity was 2.2 meters per second. And we want to know to get to the 800 meter mark. So that's probably my displacement. So again, if you just draw a picture of what's going on here, we know at 0, the velocity is 2.2. And then eventually we're going to reach an 800 meter mark. And we want to figure out how much time is it going to take to get there. So you could draw a nice little velocity time graph. I always draw myself a good VT graph when I can. And so I start off at 2.2. And I slow down. Now, I don't know if I'm going to stop. I don't know that for a fact. So I'm going to leave this as still not at 0 yet. I don't know if I'm going to stop. But I know a few things. I know that the slope is oh my goodness gracious. It's been a hard day. Okay, here we go. The slope is a negative 0.003. And I also know that the area equals 800 meters. So I could solve this purely graphically, but I'm going to use this to focus on how do you solve this using kinematics equations. So the first method would be to look at everything I'm given here and then pick an equation that's going to help me solve for that time. And I think the equation that's going to do that is this guy right here. So delta x equals v sub naught delta t plus 1/2 a delta t squared. And so now if I substitute in the stuff I know, I get 800 equals 2.2. Then my time is unknown, plus 1/2 times negative 0.003. And then times t squared. So if you look at this, you have a kinematics problem. So you can solve this using a kinematics method. So you could graph it and find your zeros. You could use a program. You could use the quadratic formula, opposite of b plus or minus b squared minus 4ac all over 2a, that type of thing. Whatever you remember, whatever works for you, that's what you're going to do. I have a program on my computer, or my calculator, that does it for me with a few clicks of the button. Yay. Now the times that you get from this are actually pretty interesting, because you actually get 2 times. So you get 800 seconds, and you also get 666.6 seconds. So that's interesting. So the reason why you get usually you'll get 2 times. You'll always get 2 times because you have a squared here, but usually one will be like a negative number. So you have to ask yourself, what do these mean? Well, if you think about it, if you're going up a hill, up a ramp, whatever, and you have to get to this 800 meter mark from 0, and let's say it was a marble, because physics just assumes all the objects will just continue in motion. As it goes up the hill, it's going to slow down. Eventually, it will reach some point where the velocity is 0. And once it does that, it's going to actually start roll back down the hill. So you have a time it takes to go up the hill, and then you're going to find the time it takes to go back down the hill. And since this one's smaller, That's the time it takes to go up the hill. This would be, I guess, if the large man fell down and rolled back down the hill. So this one is not the one we are looking for. So this is our time interval. All right, so you got to do some deductive logic. Now, if we do that, here's the cool thing. If we do that, then we can then say, okay, how fast was he now going? So we can now solve that problem. So let's bust out a different color here. So if we want to solve for part B, how fast, then the equation we're going to be looking at, we now add this, what is your velocity? And I don't like to use my time in case I made a mistake here or a rounding error, because that's supposed to be repeating. Then I like to use my original information. So I have acceleration, I have initial velocity, I have displacement. And if you look at your list of equations, the one that's going to help you is the v squared equation. So I write that down. Always write down the equation plan using. And then I can solve for what is the velocity or the speed I was traveling at when I got there. I don't know why I keep saying me. I'm sure it's some other guy. But your initial velocity here is 2.2. Square that. Plus 2 times 0.003. Displacement's 800. So now you can solve, and when you do this, you get your velocity. Don't forget the square root. People always forget to take the square root. Your velocity is 0.2 meters per second. So that's your velocity. All right? So once you have this stuff, it's actually really cool. So let's say this was a problem. You can now check yourself to make sure you're right. Well, how are you going to check yourself? Use the graph. So you know now that this point right here is 0.2. And so then this total area here is the 800. So you could say, well, if I look at this, I've got the area here plus the area here. And so I could say, well, my total displacement is equal to area 1 plus area 2. And I said, well, my area 1, let's go right here, area 1, that would be a rectangle, such as base times height. All right. So we knew this time was 666.6 repeating. So my base is 666.6 repeating times that height of 0.2 plus this number 2, that's a triangle. So the base of my triangle, well, it's 1/2 base, so again 666.6 times your height. And my height here is only 2 because I take the difference of these two, so my height's only 2. All right, and so then when I add these together, I'm going to get my 800 meters. And that's a way you can confirm yourself to make sure if you did it right. So once you do it using the equations, basically you can always use the graph to prove that your equations were valid. All right, so always take that extra time to figure that out. Just like I'm double checking on my calculator that this all works out, which it does. I swear it does. So just take the extra time, make sure you're doing it right, and confirm your answers, because you should be able to walk away from any assessment knowing if you got it right or if you got it wrong. So hopefully that was helpful, and have fun doing your Kinematics problems. See you on the flip side.